This one is one of my favorite, Frontonia Atria. Frontonia Atria. And these generally spin around, and we're looking at it 100 power. Now we're looking at it at, I think, 200 power here, 250 power. And you can see inside here, in the middle, you see that little movement by the orange there. There's a round spot right there in the middle. That's a contracting vacuole. What it does, this is a single cell organism. So what it does, the water around it permeates through it and fills it up with water, and the pressure becomes too much. So the contracting vacuole pumps water out. It works like the heart does on the human as far as pumping blood around, except this pumps water out of the system. If you didn't have this pumping sensation here, the cell would just swell up with water and then rupture. And so a lot of these organisms have a contracting vacuole. Here we've gone to 2,000 power, I believe, on this one. So we're right at 2,000 power, and there's that orange spot right there, and right in the center, right above that, is that contracting vacuole. See it contract again. And so this particular Frontonia is not doing very good because he's not moving. He's pretty much in one place right now. Something's going on with him. We'll perhaps see a rupture in his cell here. It's a single cell, so, but most of the time they're moving fast. We are now going to see this cell go into catastrophic failure for some reason or another. 11 o'clock position, in my view, you see a leakage there that starts. The cell membrane has ruptured on that side right there, and we're looking at it at about 200 power. Now we've gone to about 800 power, or 1,000, and we see this leakage right here at 11 o'clock, and that's one of the worst things that can happen to a cell. You got cytoplasm, you got organelles, you got various parts, and even the food inside this single cell organism is leaking out here very quickly. And we see some movement there to the right, downward, at a 4 o'clock position, like on a clock. And we have leakage there, we have a blowout there. You can see that massive leakage there too. So at 4 o'clock and 11 o'clock position, we have this catastrophic failure of the cell membrane. I knew there's something wrong with this cell because it wasn't moving around. These things move around really quick. And so when they stop moving, something's not right. And the contracting vacuole looked very sluggish and pumping too. So it's a terrible thing to watch these cells rupture. They're so small. Some cells live for a day or 2 or 3 days, and some cells, microbes, live for thousands of years. I mean, it's amazing. They seem so fragile. But this often reminds me of Avatar. Now, this is probably 100x, looking at the destruction of the cell at 11 o'clock and 4 o'clock position. In my view, you see the catastrophic failure of the cell membrane on both sides there. But like an Avatar, everything that dies feeds something else, and we are part of everything in the world, so to speak. And so, there's life everywhere, and certainly microbes here. Now, this is back to like 800x or 1000x. We're going to go to a 2000x. But if you look at the particles beside the membrane, now this would be at 2000x right here. And you see these particles here. But if you look at the cytoplasm and other particles outside the cell membrane, they jiggle. And I think that's the Brownian movement, what they call the Brownian movement, that causes this jiggle of those cells and so forth. But right there, where you see the orange, that was the contracting vacuole, was right there, which is no longer there. And so this is the way of life itself, and have an end sometime. But it's always sad.